This is section 8.4, compound interest. In the previous section, we talked about simple interest, which was where you earn interest on your account every year. With compound interest, you earn interest usually more often than 1 year, and the interest gets rolled into your principal so that the next time you get interest, you're earning interest on your interest as well as your principal. And that means that the value of your account grows a lot more quickly. We use the letter N to represent the number of compounding periods, which are the amount of time between interest payments. So we use N for the number of compounding periods per year. So if you're told that your interest is compounded semi-annually, then your N value is 2, it's being compounded twice a year, and each period is 6 months. Quarterly would be 4 times a year, and each compounding period is 3 months. Monthly, your N value is 12. Daily, your N value is 360 because of the banker's rule. The formula for compounding the amount in your account would be the future value, A, or accumulated value, is equal to the principal times 1 plus R over N, so your rate written as a decimal, over N compounding times per year, raised to the N times T, so the number of times compounded times the number of years. T, again, is in years. Now, generally speaking, the more time, everything else being equal, the more times you can compound in a year, the larger the future value. So if you have exactly the same principal and exactly the same rate and holding it for exactly the same number of years, you're going to end up with more money if you're compounding daily than if you're compounding semi-annually. Now, you might naturally wonder if there's a limit. You know, if compounding daily is better than monthly, is compounding every hour better, or every minute better, or second? How low can you get that? Well, there is a limit, and it turns out that the larger values you plug into N, the larger and larger and larger they get, the closer this gets to this number, which is E. It is 2.71828, so on and so forth. This is a number like pi. It never ends, it never repeats, and you'll be using your calculators to do these calculations. Most of the time, your E button will be like E to a box, or maybe E to the X. You're almost always going to need to plug in some exponent. So on this calculator, if I wanted to do E to the first power, which would just give me E, I would hit that and to get the E value. Okay. On some calculators, they share a button with ln. They're usually very close together. So if you find the ln, you should probably be able to find the E to the X button. It should be nearby. Okay. Now, if you are compounding, we call that compounding continuously. And the only time you use this coming formula is if the word continuous is in there. The formula for calculating the amount in an account with continuously compounding interest is A equal P times E raised to the RT. Now that E is the number E that we were talking about. Okay. So let's work a few example problems. First part here, we're told for all of these, the principal represents the amount of money deposited in a savings account subject to the compound interest at the given rate. Okay, 2 parts. First, find out how much money there will be in the account after the given number of years, and we're assuming 300 days in the year. And we want to find the interest earned. We're supposed to round our answer to the nearest cent. So if our principal is $8,000, we are investing at 6% for 3 years, compounded annually. So this is N equal to 1. I'm going to plug in here. The A is what we're looking for. Principal, which is 8,000, times 1 plus R over N. Our rate written as a decimal would be 0.06 over N, which is 1, raised to the NT, so 1 times 3 years. Okay, so let's do this arithmetic. Now, this is over 1, so that part is pretty easy. That's just 0.6. And then if you add 1 to it, you get 1.06 to the 1 times 3, third power. Okay, so using the calculator, 1.06 raised to the third power times 8,000. I get $9,528, and we're supposed to round to the nearest cent, so 13 cents. So the answer to the first part of the question is how much money will there be in the account after the given number of years? So after 3 years, we'll have this amount of money. The second part asks us to find out how much interest we earned. And all you have to do is to take your accumulated value and subtract off your principal to find out the amount of interest. So 9528.13 minus 8,000. So the amount of interest earned is $1,528.13. Okay. If our principal is $2,500 at 8% and we want to invest for 6 years, we're compounded quarterly. So this means our end value is 4. So using our formula, we're looking for the accumulated value, and that is the principal, so 2,500, times 1 plus our rate, written as a decimal, 0.08, divided by the number of times we're compounding, which we said was 4, raised to the nt, so raised to the 4 times 6 power. Okay, if we do this arithmetic inside the parentheses, you will get 1.02, and that's going to be raised to the 24th power. So if I do 1.02 raised to the 24th power, and then multiply that by 2,500, I get $4,021, and we're supposed to round to the nearest cent. That 3 is going to keep it the same, so a 9 cents. So our answer to the first part is $4,021.09. For the second part, how much do we have in interest? We take the amount that we end up with and subtract off the principal, and you get $1,521.09 in interest. One more of these. So on this one, we're compounded daily, so our end value is going to be 360. And for 20 years, we're going to be dealing with big numbers here. So our accumulated value would equal our principal, 25,000, times 1 plus our rate written as a decimal, 0.055, divided by the number of times we're compounding in a year, which is 360, raised to the nt. So that's going to be 360 times 20. Okay. Now, you want to be careful entering this into your calculator. I suggest doing it in steps, not entering it all in at once, because it's very easy to make a little mistake. What I'm going to do here is I'm just going to quickly calculate what that exponent should be, so I don't have to enter that part. 360 times 20, that exponent is 7,200. Okay, so I'm not going to get a nice pretty decimal when I do this division, unlike the ones I did before. So I'm going to start off with 0.055 divided by 360. Ugly decimal. Add 1. So now I have the parentheses. Raise it to the 7,200th power. Now multiply by 25,000. And we get $75,097 and to the nearest cent, 84 cents. So that's how much money we would have at the end of that period. So how much do we make in interest? $75,097 and 84 cents minus the $25,000 we originally invested gives you $50,000, $50,900, let's try that again, $50,097.84 in interest.